And congruent triangles continue to help us prove theorems. Before we learn our next theorem, however, we do need to learn another definition. This definition is the distance from a point to a line. And that is simply the length of the perpendicular segment from the point to the line. So if we wanted to find the distance from point K to line N, we would have to find the perpendicular segment and measure that. Likewise, to find the distance from point H to line N, we would need to once again find that perpendicular distance. So once we have the perpendicular distances, we can measure them. So the distance from point H to line N is about 1 3/10 centimeters. And from point K to line N is about 3 3/10 centimeters. I have people ask me all the time, why do we use the perpendicular length? Well, notice what happens when we move off of the perpendicular even a couple degrees. Notice now that the length has gone from 3 3/10 centimeters to nearly 3.5 centimeters. So the perpendicular distance is the shortest distance. And doesn't it make sense to always use the shortest distance? That's why we use the perpendicular. With that in mind, now let's take a look at an angle. How does an angle use this distance from a point to a line, you ask? Wait, I'll show you. First, let's bisect this angle. Do you remember doing that? We put our compass on V, and we create an arc that goes through both sides of the angle, and then we move our compass and put the point of our compass on point A and create an arc, and then we move our compass point to point B, and we create another arc, and where those two arcs intersect and the vertex of the angle, we draw a ray through that. And so now we have ray VP, which is the angle bisector of angle AVB. Now that we have that done, I'm going to clear off all those arcs we used to make the angle bisector. And now let's take a look at the distance from point P to the sides of the angle. Or in other words, the distance from a point to a line. Or in this case, a point to two lines. Well, wait a minute. Those are perpendiculars, which means they create right angles. And all right angles are congruent, so we have a pair of congruent angles. And because we bisected this angle, those angles down at the vertex V are also congruent. So we have two pairs of congruent angles. And segment PV is congruent to itself by the reflexive property. Oh my gosh! That means we have two congruent triangles! And if the triangles are congruent, their corresponding parts are congruent. So notice that point P is the same distance away from one side of the angle as it is the other. Oh, do you see a theorem here? I do. It's called the angle bisector theorem. And it states if a point is on the bisector of an angle, then it is equidistant from the sides of the angle. So there we have point P, and it is going to be on the angle bisector of angle GVU. That means, by this theorem, that the distance from P to G and the distance from P to U are going to be the same. So now let's use this in a problem. Woohoo! What is the length of segment HR? Let's see here. I notice that we have a couple of congruent angles here, which means that point H is on the bisector of angle NTR. And I also notice that segment HN and segment HR are perpendicular to the sides of the angle. That means that our angle bisector theorem applies and that those segments have to be equal in length. Oh, now there is an equation we can write. The 5x has to be equal to the 8x minus 24. So if we subtract 8x from both sides of the equation using our subtraction property of equality, and then divide both sides of the equation by -3 using the division property of equality, we find out that x equals 8. But wait, we're not done! Because we weren't asked to find what x is, we were asked to find the length of HR. So now all that I have to do is plug 8 into our equation. 8 times 8 is 64. 64 minus 24 is 40. Now I do want to point out something here. Since HR and HN are the same length, I could just as easily have plugged that 8 into the 5x, and 5 times 8 is 40. That might have been a much easier way to do that, right? Keep that in mind as you do some problems on your own, and then you're done with your lesson.